Okay, here's 3.4. We're doing something new now, so kind of stay with us, and I'll answer questions for you guys later. Okay, 3.4. This is the part, second half of 3.4. Example 3 is actually a really good example of when you would want to do inverse function in real life. The Asian income example is not a very good one, because you can imagine using your income to guess how tall someone is not a really good strategy. Because the relationship is so vague, it's not science, it's not natural law, so it kind of, does it make sense that to actually match that for two people with a, if I find a 5'7", if I find a 5'8" version of myself, especially at Morrison, he's going to make the same amount as I do. Mr. Driven makes the same amount as I do because we're a missionary school. We all get paid the same income. Do you know that? We all make the same.
Everyone in
the yeah.
Even the principal?
Yeah, I mean, as much as Mr. Robinson. Now, he works here longer. He had more. He probably had more credential than I do, and that kind of add up. But the same, if you're same credential, then you get paid the same.
Wait, this is out of topic. Do you do like the stock stuff to get to invest?
Do I buy stocks? Yes, I do buy stocks.
Has it ever
I do have some Apple stocks. What?
Has it ever crashed?
Has it ever crashed? No, I've actually been doing pretty well. But I don't put a lot of money in. I'm a poor missionary. I don't have a lot of money. We can talk about stocks another time. However, my point is that when you do economics or kind of survey studies, it's a little bit more subjective. Does that make sense? This is why, if you remember in 8th grade when you do science experiments, who did you do it with? Miss Chang? Remember how you would, a lot of you want to do behavioral study, and she discouraged you from doing that? Like, not that it takes time, like the ones where some, remember there's one, like psychology stuff, looking at words that's red car, blue cars, and see which color help you remember stuff. The problem with behavioral study is that it's so subjective. Just the fact that the person who gives you the exam is a girl or a boy, that might affect the result. How big the room is when you give the exam also has an effect on the result. The size of the font on the card. There's so many things that you can't control. And that's why the high to income one is interesting. Kind of have a shocking value, that's why I use that example. But it's not actually a really good example to do inverse. Okay? If you do that, then everyone at Morrison, all the teachers have the same height. We all need the same amount, but you know that's not true. However, in this example, example 3, you have something that's based on natural law. This is physics here. So the resistance is kind of the weight that you're pulling is a linear function to the length of the band. That makes sense? The longer you pull the band, the amount that you increase to the pull is actually a direct relation. So it's 3/8 to the length. And that's always true. Does that make sense? It doesn't matter if you're a guy pulling it, a girl pulling it. If you use that band, it will always stay in that linear equation. Therefore, currently the equation gives you, you can measure it. So I pull it this amount. How much weight does it take to pull it that far? A little bit more. Once you figure out it's linear, you can now do an inverse model, and I won't do the actual thing because you already know how to do it. Okay? You can do a inverse function, and now this new equation is a lot more useful because you can decide how many pounds you want to pull in your exercise, and then figure out how long the band should be. Does that make sense? Okay, perfect example of how you actually use inverse function in real life. Because natural law, the inverse will be always true. Now, this is the part we haven't gone into in 3.4. However, I did kind of briefly touch on it when we were doing the explanation on the quiz. Inverse function, the graph of inverse function, doesn't matter what the function looks like, will always flip over the 45-degree line. Okay? It's not some amazing fact. It's actually common sense. Again, you're just flipping the axis here to there, and there to here. So obviously, your graph would just flip over, right? It's like saying I draw a, what can I draw? Let's say you have x and y, and you know I can draw a Pachaco. You know who a Pachaco is? He's a puppy. No, it's a really ugly version. Anyway, so let me group him. Oh, he's already grouped. Perfect. So if this is on my graph, right? Y would be the height. That's just how tall he is, right? And X is how fat he is. The fatter he is, actually, the cuter. But anyway, if we switch them, let's clone this. We would have to turn it sideways and flip left, right. Oh, did it flip? No, it didn't. Try again.
It did. Wait,
Did?
no, just
No, it did. Flip left, right. It's not doing it.
It has to be straight.
You think it had to be straight? Ah! Turn Pachaco into text. Okay, let's come back. Let's try that again. You have to flip. Oh, it's not doing it for me. Anyway. Lane. Then you have to flip it. Right? But now the height goes this way, and how chubby he is goes that way. However, when you call it inverse, you would still call this y and this x, but now your height is your input, chubbiness is your output. Now, the reason why they're introducing this right now is that if you think about this, then it's very easy for you to look at the original graph. It's very easy for you to look at the original graph and figure out if the inverse is a function. What is a function?
No, like, same line. This is the same line.
What's a function? Definition of function. Come on, everyone. Everyone should know this by now.
X, Y equals.
One input is one
Every input has exactly one output. A what? A relation. A relation where every input has exactly one output. So the vertical line test used to test if that graph is a function. Because you see if every input only has one output, right? Are you with me? But the 45, when you flip it over the 45-degree line, that graph will now look like this. So your vertical line test is actually, what's going on here? Is actually the horizontal line test of the original graph. Does that make sense? So just by looking at this x to the third graph, my sleeve is in the way. You know that this one, the inverse function, will be a function. Inverse equation. I don't know how you want to call it inverse function. For this one, you know the inverse will not be a function. Because the graph will look like this, and this horizontal line test will be the same as a vertical line test of the inverse. Are we together? Is that okay? Okay. Let's look at an example. Find the inverse of x squared when x is greater than 0. What does x squared look like? The parabola, right? They only want x is greater than 0. This is the f, which means my f of -1 will flip over the 45-degree line, which will look like that. That make sense? Okay. Why does it say x greater than 0? Because if it doesn't, it will also include this part, which means it will include this part. Then your f of inverse of f would not be a function anymore. Right? Because now there are two outputs. That's why we go on the bottom half so that both of them can stay as a function. Okay? So if you look at this graph, just by looking at it, is the inverse a function?
Yes.
And how do you know that? There's only one point of x for every y. And then find the inverse. The inverse is just x equal to 2y cubed plus 1, x minus 1 equal to 2y cubed, x minus 1 over 2 is equal to y cubed, third root, and y is equal to, so you can follow this, 4x minus 4 over 2. Okay, does that make sense? Notice what I did there? I multiplied top and bottom by 4 inside the radical so that I get a full 8 that comes out. And then I only have radical on the top. Okay? So remember not to have radical with a number on the bottom. Okay, let's try a couple problems. I've talked long enough. Let's try number 9.